Well, we've just finally gotten to dealing with an operating system. We've talked and hinted about Windows here and Windows there. So let's learn all there is to learn about Windows forensics. Not in 45 minutes. It's going to take some experimentation on your side. And then here's this other problem. I walk into a client's site and I say, I've learned this operating system. The current operating system is this. Current operating system for Windows is Windows 8.1 or 2012 R2. The client says, well, I've got XP in Windows 2000. I don't know that. You've got to know them all. But wait a minute, hold on a second. XP is on the downside. In other words, it's got smaller and smaller market share, and it's also not supported by Microsoft at this point. Why are you in the field still using XP? It doesn't matter. Their business choice is their business choice, and we have to live with that. So we have to know all the operating systems that are being used at this point in time. That's why you can't be an expert in Linux and Windows forensics at the same time. Well, maybe you can, but there aren't a lot of people that are doing that. They're doing one or the other. They're kind of picking and choosing at that point. Let's talk about you for a second here. And here's a problem that you're going to run into. So right now, if you're taking this, you're probably not a forensics investigator because you're probably getting into the field of forensics investigation. So you're not making choices at this point, and there's lots and lots of data that's been built up and lots of tools that have lots of scripts against old operating systems. For instance, FTK and Ncase have all of these filters to find Windows XP registry keys. And the understanding of exposing those registry keys is unnecessary. They're there, they know about them, they're in the scripts, and they'll go in and they'll look for that information, those artifacts that they need to either prove ownership of the machine or prove that a particular user has access to this file, which is making them guilty. So you've got to know them all, but the current one's really what you want to focus on. So whenever you're watching this, I would imagine this will probably be, you'll probably be really current with 8.1 or 2012 R2. What I'm saying to you is learn those operating systems now, because there's already going to be that expertise with the forensics investigator, the senior forensics investigator, and you're going to be a junior. So if you're learning the new material now, by the time you get to that point where you're a senior, where you've got 3 or 4 years experience, then what will happen is there'll be lots and lots of activity on the operating system that you're learning now. 8.1 and 2012 R2 will be present. They will be where most forensics investigations are going to be. So what you want to do is you want to shoot for the target that's into the future. You don't want to learn a lot of the stuff that's from the past. Now, you still have to learn some of it because some of it's on the test. You still have to learn some of it because you're going to encounter it and you need to own your operating system. You need to know your operating system. But there's so much material on these older operating systems that it's going to be a lot easier for you to get into that bad habit of looking at XP and talking about Vista and those kinds of things instead of flipping over and working on 8 where there's not a lot of material. So what I'm telling you is I'm challenging you, learn 12 R2, learn 8.1 really, really deep and richly after you take your test. And focus most of your energies there while you're learning and you're becoming that journeyman in forensics. Now what we're going to do is we're going to mix across all of them because I want to give you a little flavor of the new settings and the old settings, and then also there's some stuff that we have to cover because they're going to ask you about this particular registry key on the exam. Now, we're going to break our Windows forensics exploration into kind of 2 major chunks. The first chunk is understanding the analysis, password security, volatility, and memory dumps, and that doesn't change for any of the operating systems. And then what we're going to do is we're going to spend a large majority of our time digging into the registry. We're going to look at auditing events, operating system data, web artifacts, but we're going to spend a lot of time in the registry because the registry is the best thing to investigate as a forensics investigator, because it tells you information that you can't get anywhere else. And if the user has changed or altered and tried to hide their activities, the registry exposed this right away. Now, originally when I first did this course, there were 160 slides on registry settings, and I thought that would probably be mind-numbing for you all. So what I'm going to do is I'm going to talk about some of the really juicy registry settings, what they get us, and you're going to have to say, okay, well, what will this other set of registry settings get? Well, Dean, I want to know about all the registry settings, and I'm going to point you toward the two resources, one free and one paid resource out there where you're going to spend most of your time. After this course is over and after you've gotten your certification, send me a hi and say, hey, I've got my certification. Where am I going to go next? And the answer I'm going to say back to you, along with a couple of other things, because I'll ask you questions. But what I'm going to say to you is learn everything you can about the registry of the current versions of the operating systems from the people who know it very well. And that's very different from when you're with that senior investigator and they say, run this ncase script or run this FTK script. You're not going to learn anything from that because you won't know why that registry key is so important. Because it's scripted, it's all buried down inside of there, and it just says, here's the evidence that we actually care about. And then that investigator already knows how to explain that to the court, and they may or may not be able to explain that to you. They've gone past all that. One of the really cool things that we're going to talk about last is the thumbs.db. This is overlooked by a lot of forensics investigators unless they're actually looking for CP. I think that the thumbs can give us a lot of data that we could use. That database can give us a lot of information that would help us to go further. More and more of the information that we're dealing with is visual. So what will happen is people will take a picture, they'll sync it up with their computer, and all of those pictures go there. That tells us where they were. Remember, those pictures also have data behind them. They have metadata behind them that can place a person at a particular scene, maybe the scene of the crime, at a particular time on a particular date. And it can GPS right down into that. And we'll get into the imaging stuff later on, but realize that the thumbs is imaging and that's where everything's going. First, we need to talk about static and dynamic. We're going to look at static analysis and dynamic analysis of an individual executable. You're given not a whole image. At first what you're given is, we don't know what this exe does, and we think it's malware. You have a choice at this point. You can do analysis on the dead, static executable, which gives you some good information. Or what you can do is you can put this into a dynamic situation, install it on an operating system in a sandbox, and then evaluate the activities that occur while that's running. We're going to look at both of those. Now, when we talk about static and dynamic, we're talking about one executable here, not the whole operating system. So first we start off when we get the machine, when we get the executable, we document everything, just like we said before. We need to know, where did this executable come? Where was it sitting? The full path and location of the file. Well, it was in Win32 it was in Windows System 32 blah 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 sub directory. Well, is that directory created by the program, or is that directory created and then the program puts itself there? So you need to know where that executable sits. That will give you some clues, especially when you're looking inside the registry itself. You need to know what operating system and what version. Usually when we're talking about malware and we're talking about that operating system and version, this malware is only good against these unpatched machines of this variety. And if we were to actually run the patches and have a fully patched machine, this executable may not work when it gets there because it needs certain facilities that have been clogged up or blocked from a security standpoint. We need to know what file system it is. Is it NTFS or is it FAT? It's a very big difference for malware when it comes for NTFS and FAT because there's less permissions, it's less granular, and you can move around more freely on the FAT side of things. Also, that gives notice to that particular executable that if there is slack space, here's how we're going to take advantage of that slack space. That slack space is different for FAT versus NTFS. So we need to know what file system it was loaded onto. What user accounts are present on the machine? Was this installed as an end user that escalated their privileges, or was this installed with an administrator account, or did it not use any account whatsoever and got straight down into the core of the operating system somehow? So know what user accounts are present on the machine, and then finally the IP address of that individual machine, because there may be some communication back to that area. So now we do all this documentation to figure out about this one executable. This is primarily for malware analysis. So let's talk about static file signature analysis. Most of the time, what you would say is this is carving. That's what you would call it. Because here's what happens. An adversary says, I don't want this to be named malware.exe. I'm going to call it system32.dll, something that you would think is reasonable to be there. And they'll rename that executable. They may even stay, instead of system32.dll, they may call it something like annualreport.xls. And that's the thing that's seen by the end user. It happens to be that there's some other registry settings back in here that actually, well, it's not really an XLS file. It's actually an executable file. But externally, what you see, that's an attribute of the end user communication. It says, oh, here's an Excel file. That's not mine. I'll just leave it there. I don't know why it's there. It's probably there from an old install. So I can rename the particular tool. I mean, I can rename the particular binary, and you'll believe it, and the interface will lie to you and tell you that. That's, for instance, like when I send zip files to certain people, they say, well, we don't accept zip files. Okay, I'm going to change its extension to .txt. And then it passes through their email server, they get it on their side, and they rename it back to .zip, and it allows them to uncompress it with unsophisticated security devices. Now here's what doesn't change. You can change the extension on anything and let the automatic file association and the graphical user interface give you a whole bunch of data, but you can't change the header. I say can't change. I'd say it's almost impossible to change the header and get that file to execute correctly. Headers rarely change. So what we're doing is we're doing, in static file signature analysis, we're collecting those first 20 bytes of the file and saying, what is the header information? That will tell us what kind of file this is. If it's a data file or if it's an executable, it's going to have a different pattern inside of there. So we're looking for that specific signature, that magic number that tells us, that hex magic number that tells us it's that thing. So here's what we do. In executable file analysis, we gather all the information and process it. We can do it static or dynamic. In static analysis, what we do is we say, okay, this is not a running executable. And the process is relatively simple because we scan it and we get external data on it and say this particular executable is this length. Are there any hash values out there? We could analyze it with PE header if we wanted to. There are plenty of header analysis tools that are out there. I just picked PE for this so that you'd know about a new tool. Are there any import or export tables that it actually creates, and can we analyze those things? That's all you're doing in static analysis, and that's the end of it. Dynamic analysis takes a lot more time because we're running the executable, and we can't do this on our open network on our regular machines. So what we have to do in advance is set up our virtual lab. And you're probably already doing this as a forensics expert for the operating systems that you use to test on, and you have these reference images. So in advance, you're going to collect past and current operating systems. We talk about, from Microsoft, we talk about TechNet or MSDN. You're going to build that standard virtual machine, and then you're going to add some tools to that standard machine that will actually capture the state of a particular executable before and after. Now, sometimes you're installing these things, sometimes there is an installer, and sometimes it's just an executable that starts doing all sorts of other stuff and sending all kind of registry keys down. So you're going to add this snapshotting tool. It's called an MSI creator. What that MSI creator does is it says, this is your reference machine without the executable, install the executable or actually do the install routine, and now I'm going to snapshot afterward what are the differences to the machine besides this one file. Did it change any other files? Did it change any registry settings? Because what the MSI installer wants to do is it wants to gather up all that information to create an installer package to put it on the next machine. That's not its normal purpose, is to do malware analysis, but you need to know what's changed on the machine, and an MSI snapshot tool will actually help you with that. I would add additionally to that some sort of file integrity checker to see if that executable actually manipulates any other key files on the machine. When we talk about file integrity checkers, what we're really talking about here is tripwire. Then you're going to prepare a listening application for your wire. That's usually Wireshark. We'll look at what happens in the next segment. We'll talk about the dynamic analysis process as it's going live.